Hello, my fellow mathletes. Root Beer here, and I'm going to be taking a look now at question number 21 on our grade 9 Pascal paper. What have we got? A coin travels along a path that starts in an unshaded square in the top row of the figure. So just top row, not necessarily top right, so I guess it could start here or here. A diagonal move takes the coin to coin either one square down or one square left. Takes the coin either one square down and one square left, or one square down and one square right, just in case we started up here or we wanted to jump down here. Okay, how many different paths from the top row to the bottom row are possible? Alright, so it's a counting question. That's what we're going to need to figure out. So I can see there are going to be two cases. Either we start in the corners, because a path from the top corner down can just be mirrored for the one over here. And then, of course, the other situation will be right in the middle. So I think two cases. But how do we count something like this? Well, when you're counting paths in a figure like this, a graph like this, one might even say, because the shaded squares don't even matter here. There we go. Well, so we'll shade them in, but they are largely irrelevant here. So how do we count things like that? So I'm just going to do start with the top left. We're just going to, whatever number I get, we're going to double it for starting at the top right. So we'll just, whatever number I do here, we double. So what can we do? Well, there's only one way we can go. So there's one way to get to this square from the top left. Now from there we've got options. We can go down here, or we can head down here. There's one way to get to each of these squares. But here's the interesting thing. This square right here, there's two ways to get to that one. Down, down, and back, or down, over, and back. Two different paths to get to this square. And there's one path to get to this square. You may have seen something like this before with looking at Pascal's triangle, or counting paths in other situations. But basically, you just start by saying, well, how many ways are there to get to something very basic? Like, there's one way to start here, and that's to start there. And then, just as your roots diverge, the number gets copied, and when roots converge, when paths meet, the numbers get added. So there's two ways to get down to this corner. Follow either of those two previous paths and then just jump down to the bottom left. But there's three ways to get to this middle square. Two ways coming from over here, one way from over here, so that's a total of three different paths, and you could write them out if you wanted to. And then there's one way to get down here, so that's a total of 6. So we're going to add on another 6 for coming from the top right. Okay, so now what do we do for the middle? Well, the exact same thing. Same reasoning. We're just going to have different numbers of paths. So you'll notice starting from the middle, you have two ways you can go right away. Each of those leads to one way to get to that particular square. Okay, so I'll do red for fun. One way to start there, one way to get to each of these, two ways to get to the square, 2 spots below, one way to get to each of these. 3 here, and those 3s move into the corners. That's the only way to get to the corners, is by following one of the 3 paths that leads me to that red square. And then in the middle, we've got 6. So that's 3 plus 6 plus 3, that's 12. So that's a total of 24. I bet 18 might be one of the answers, just in case you forget to count The other one's there. But what have we got here? 24. There is no 18, so that's okay. But there we go, 24. So that's going to be our answer, D, 24. And that moves us right into our next question, question 22.